Kia ora koutou and welcome to our chlorine-free review guest lecture. This session gives an opportunity for interested people to learn about the chlorine-free review that we have undertaken here at Napier City Council in greater depth, and to understand our path to a chlorine-free future. Water is our number one priority here at Napier City Council, and we have planned significant investment to improve the quality of our drinking water. So today we have a panel of our water experts here to explain the process to date, and then we will move into a question and answer session at the end. So I am the Mayor of Napier, Kirsten Wise, and I'll pass across to the rest of our panel to introduce themselves.
Hi everyone, I'm Catherine Bailey. I manage Three Waters Reform, and my role in this project has been to facilitate the process and the project on behalf of Council.
Oh, hi, I'm Peter Hillis. My role in the project has been the technical lead for the project. I've worked in the water industry for over 40 years and based in Melbourne.
And my name is Tony Urquhart. I'm the consultant project manager for the project from PDP, and I'm based in Auckland.
Excellent, thank you for that. And I will now just ask Kath if you wouldn't mind talking us through the agenda, and then we'll move into the presentation.
Thanks, Kirsten. So we're just going to do a little bit of an introduction as to why we've done this project, full stop, what the process was that we went through, and as we went through the project, what were the findings and the costs and options for moving towards chlorine-free. I'll also talk briefly about the peer review that was undertaken by a GHD, and then we'll have a session at the end where Kirsten's going to ask us some questions so we can get a little bit more detail and get more involved in what this review was about. Okay, so I'll start off. In December 2019, we had a very long council meeting where we talked about all things water. And at the end of that meeting, it was decided to go ahead and do an external review to understand how hard it would be to get to a chlorine-free state and what would be involved in the costs. So early the next year in 2020, we went through quite an involved procurement process. We looked at how we could get as many different groups as possible to put their information forward to undertake the review. So we had an expression of interest. We had 13 parties who downloaded the documents for the review. And then we had 7, I believe, who actually put in their information around their skills and experience and their group and who would actually undertake that review. We had a tender review panel as part of council staff, and that was reduced to a shortlist of 4. Council had said at the 2019 meeting that they wanted to be involved in the final decision over who we would go for to do the review. So the tender review team put together a recommendation to work with PDP and their partners to undertake the chlorine-free review. So that went to council, I think it was May 2020, and the project started in around about June. So we've been working on this for the last sort of 8 months or so. We now have the final report, and part of this is to look at what the findings were from that process. So I'll hand over now to Peter to take us through how the review was undertaken.
Thanks, Kath. First of all, just take you through the approach and how we tackle the problem. So, like many projects, there's a sequence and an order that we generally run through. So we started off with the planning and information review, made sure that we identify who the key stakeholders were and what their involvement was. Part of the team included international experts, so PDP partnered with 3 experts in water treatment, chlorine-free network, on system management, and public health science as well. So the first thing we did was an international review of chlorine-free supplies, and that was really looking at supplies globally, so that we get an understanding of what those systems look like and how they were operated, and any key lessons that we could learn. And from that, we developed a series of options. And the options obviously included chlorinated and chlorine-free options as well. They were presented at council workshop, and then we came down with a final short list of options. And then those final shortlists went through sort of technical and financial review using multi-criteria analysis. And out of that, we produced a preferred option and a roadmap. And the important thing, I guess, to say about the roadmap was what we wanted to do was ensure that we developed a prudent approach to moving to chlorine-free, to make sure that investment was strategic and planned, and any short, and medium-term investments fitted in with the long term. This was presented to Council at a second workshop, and the final report issued a couple of weeks ago. In terms of stakeholder engagement, it was important, obviously, both for the Council and the project team to get input from as many stakeholders as possible. We identified the list here, including the Mayor, iwi, Council staff, Ministry of Health, the health regulator and the water regulators, local groups such as the Guardians of the Aquifer, ex-council staff as well. So we had conversations, met face to face with pretty much everybody, and that was really to make sure that we understand the positions of each of the stakeholders, and we could ensure that we take account of any specific needs and address any specific concerns that were raised. Just moving on now to sort of the review findings. Obviously, one of the key changes that's happening in New Zealand are changes to the water industry regulation. So after the Havelock North incident, there was a drinking water inquiry, which is now being implemented. The findings that are being implemented through the Water Services Bill. There's a new industry regulator, Tamata ROI, it's been established and will take effect from the 1st of July. And as part of the process, we met with people advising the setup of that organisation, such that we got good insight into what their expectations would be. But one important note is that residual disinfection, generally chlorine is a mandatory requirement, with exemptions only where the water supplier can satisfy Tamas RI that they have water supply that is safe. And the advice is that those will be exceptional circumstances and rare, but there is a pathway to achieving an exemption. And that includes maintaining multiple barriers against contamination. That includes both source water protection as well as treatment. And then demonstration that once you've produced potable water, that then you have a secure system for distributing that water to the customers. We also have to have high levels of monitoring, and that really is about maintaining the quality and demonstrating maintenance of that quality in the system. Backflow prevention devices on pretty much all properties, and achieving leakage levels of about 5%. And that number really comes from the benchmark for other chlorine-free systems operating outside New Zealand. So what's the characteristics of Napier's supply, and therefore how do we use that? How do we transition from where we are to chlorine-free? Well, all water, as most people are aware of, from locally sourced artesian bores, and chlorination at source using temporary chlorination facilities. Now, pre-27, the system was chlorine-free, but after Havelock North and the detection of some E. coli in the system, chlorine was adopted. Now, the source water is good quality and it has low organic content, which is important. It does have iron and manganese present, which is common in lots of groundwater systems. And it is the chlorination of water containing iron and manganese that results in dirty water customer complaints. The Napier system has very high peak summer demand, and that puts a strain on the system, both in terms of the reservoir and the total system capacity. And we do have evidence of some surface contamination from data that we've collected. We can't ignore the fact that we're in a seismically active zone, and therefore that presents a risk both to the pipe network and also service reservoirs. giving us an area of vulnerability. It's one open network with limited control, and there are no major water meters, household meters, or district metering areas as well. And typical leakage levels are much higher than international chlorine-free systems. So when we look globally, what were the lessons that we learned, and what was a chlorine-free system look and feel like? Well, the first thing we have to do is really understand our source and match our treatment to the source. So let's make sure we have adequate treatment and good source protection. We have to make sure that when the water leaves the water treatment facility, it's transmitted in a secure manner and stored in a secure and ingress-free manner. Water metering is crucial, and that really is to understand water losses so that we can get a good handle on water in and water out. Backflow prevention, to prevent any back siphonage and contamination of the system from such things as swimming pools and any industry or small business, as well as household. And what we're trying to achieve is less than 5% leakage. And that's an achievable target. There are systems around the world operating like that, but what it requires is the water network being upgraded, monitored, and improved in terms of asset management as well. We've developed a robust replacement program, and also community buy-in is very important into achieving a chlorine-free system. So what is important is that the community values water, it values the quality of water, and it values the end-to-end process of those involved in the delivery of water services as well. So in terms of the options and costs, we'll just talk through the 4 or 5 options that we developed through the shortlisting process. So in terms of chlorine, there's a couple of chlorinated options. There was the status quo plus, which was additional work required above maintaining the system as it previously had. And then we also had a light version of that as well. There's a chlorine-free option, which was the Dutch model. So we used the approach taken in Holland, which was really around what we've talked earlier around good understanding of the source, water, good protection, the treatment plant, and maintenance of water quality through the system. We looked at point of use as well, which was looking at the introduction of facilities at each property to remove chlorine and provide some local disinfection as well. And then we also looked at a couple of options. One, obviously going back to the pre-2017, before we added chlorine, and obviously then there was another option, which was to look at that plus some acoustic sensors and fixing up the service reservoirs and improving water hygiene practices. So the costs of the options came out. So status quo was the planned investment, which was part of the long-term plan, which you can see there spread over sort of 20-year period was going to be 178 million. Moving to status quo plus light was 209. And these are, so that's an additional 30 million. And then status quo plus 21, and to go chlorine free 284 million. So if you look at the sort of marginal costs of moving between status quo plus and chlorine free, we're talking about an additional 63 million dollars spread over a 20-year period. So in terms of the evaluation criteria and how we get from those 4 options down to a preferred option. So we use a multi-criteria approach, and this is both looking at financial criteria such as capital costs and operating costs, and then assess what we call non-cost criteria. So the ability to gain a chlorine-free exemption, and that was about legal and compliance risk, the public health risks associated with all the options, the time as well. So how quickly we could achieve the outcome. The complexity, so that really looks at both the system complexity, the operability and operational complexity as well. Water security, so in terms of the options, which one gives us the most sustainable and reliable source, and obviously systems where we have less leakage give additional benefits in terms of security, and then also public and cultural acceptability as well. So in terms of the option evaluation, this gives really what we call a shopping list. So on the left-hand side here, we've got a list of components of each of the options. So bore protection, low manganese boreholes, monitoring, iron and manganese removal, chlorination, UV. So you can see the list is fairly extensive in terms of the component parts of each option. And then we go from status quo plus, the Dutch model and point of use. But I guess the point here is to look at that there's a lot of commonality in the options. So therefore, what we're looking to do is, as we would maybe transition to a chlorine-free, that we invest in component parts that align with a long-term strategy. And obviously there are certain elements that are unique, such as the leakage levels for the status quo and point of use are very much different than the leakage levels required for the full chlorine-free option. And then finally, obviously, the point of use is specific to the point of use option, the point of use device. But I guess the point we should also make is that that's not a panacea. We still have to do a lot of other work, even if we did go to the point of use device. So what was the outcome? Well, the Dutch model is the preferred, and that's really its ability to obtain an exemption. So that's the preferred chlorine-free option, and the status quo plus is the preferred chlorine-based option. The strategy, as I mentioned earlier, has to be based around short and long-term decision making, and the approach, as I sort of briefly touched on, has to be phased and targeted. Has to be evidence-based, but more importantly, we have to ensure that throughout the transition, we deliver safe and secure water as well. So what are the steps to going chlorine-free? So this is the approach that we adopted, and as you can see, we start with iron and manganese and UV treatment at the boreholes. Now, that could be low manganese boreholes with optional removal, dependent on whether we can identify low manganese boreholes. UV disinfection on all bores, that's becoming mandatory in the regulations, and upgrading the existing chlorination systems, and that's partly to make sure that we're in much better control of the dosing and get a more consistent chlorine residual in the system. After we go through step one, we then move into step two, and that's really then moving downstream from the treatment process and looking to improve some of the infrastructure, such as the reservoirs, and then start to reduce leakage and improve the network operations as well. And this will include maybe moving or we previously would move from a number of dispersed sites to a small number of sites, which then gives you the ability to transmit water directly to the reservoirs and then feed the system from the reservoirs. Again, gives us more control. The introduction of district meter areas, that's an installation of a number of water meters in the system and dividing the system up into discrete areas. And then looking to get leakage under control to at least 15 to 20% and get a good handle on what the baseline is. So there will be investment in mains replacement and repairs here as well. The other key thing is improving water hygiene practices, and that's end-to-end, so making sure that everybody involved in the production of safe drinking water is aware of the impact they can have on the hygiene of that water. And also increase water quality monitoring. It's one of the important things we have to demonstrate in moving to a chlorine-free system, is to ensure that we have enough evidence and data when we submit our exemption. There's a whole point here, which is what we're they're doing there is, which is establishing and ensuring we get good performance and get a good understanding of that performance. And then we get into a period of reducing leakage, and this is really targeted reductions and trying to get down to that 5%. And within that, we'll be introducing universal metering, universal backflow protection, a smarter network with monitoring and control improvements, and also continuing our water quality monitoring. And so then once we get that really good picture, we've got a system operating, we've demonstrated that we can maintain quality. We then would move into a reduced chlorination approach where we would gradually reduce and continue monitoring. This was very much the approach adopted in Holland, and then going full chlorine free. But I guess the caveat on all this, and the important thing for us, is to keep the Tamat ROI on board throughout this whole process and keep that communication going, such that the submission and successful application for exemption. So just in summary, we feel we've developed a clear path to chlorine-free water supply for Napier. Unfortunately, there is no quick fix. There are clear criteria that we've got to be met to gain a chlorine-free exemption. There are constraints. Obviously, there's financial constraints, workforce constraints, ability just to carry out and spend the money and replace the amount of and repair the amount of pipes that we have. There are knowledge gaps. There's things that we know and things that we don't know. But really, the three pillars of a successful transition is, one, public health is paramount, and we have to ensure that we protect that throughout this process. The infrastructure that we put in place and making sure that infrastructure is fit for purpose and well designed and well operated. And then asset management, which is about the overall operation, maintenance, and custody of the system as well. This presents a great opportunity for Napier to create a world-class chlorine-free water system and be really groundbreaking in sort of leading the way in New Zealand of how to successfully transition from a chlorinated to a chlorine-free system. I'm now going to hand you over to Kath, who will take you through the peer review process.
Thanks, Peter. So obviously we had Peter and his team and Tony who undertook the review for us. We were also requested to have a peer review of that to make sure that we were on the right track. So the process that we went through is we chose GHD to assist. They've been doing work with other networks in New Zealand around how they can go chlorine free. And they recognise that the goalposts have essentially been changing over the last year or so with the work that Tamat Arawai have been doing, and changes to drinking water standards, etc. So they came in and we wanted a collaborative process. So they read the review first, came up with their thoughts. They had a team of local and international water industry experts, including those overseas in the Netherlands who deliver chlorine-free water, sorry. So they looked at it first, had their comments, then they worked with the team to make our report better, essentially. So it was a collaborative process, which was very good for the output of this report overall. So essentially, in summary, GHD agreed with the direction that PDP had taken, and they agreed that it would be a time-consuming effort and fairly not prohibitive, but it would be costly to get to a chlorine-free situation under the changing regulations that we've got in New Zealand now. They felt that the report clearly identified risks and the ability to get the approval from Tamat Arawai for an exemption pathway. And yes, they just agreed that it's absolutely possible for Napier, and given that we've got such good source water, that is an added bonus. And as Peter's mentioned, it's around making sure that we keep that water quality as we distribute the water through the network. So the peer review document and the main document are available on our website if you want to have more information around that.
Excellent. Thank you very much, Peter and Kath, for talking us through the process and the peer review. As I mentioned earlier, we now have a number of questions which I'll be putting to our panel members. So first up, we have a question here for Peter regarding what is causing our dirty water. Why is it brown, green or yellow? Is it unsafe, and why don't we just remove the manganese?
Yes, so the main contributing factor to dirty water, it's really the presence of three things: iron, manganese and chlorine. So we looked at both research and also empirical evidence and really shown that the presence of manganese actually exacerbates the accumulation of iron within the network. And as that iron accumulates, it gets dislodged during normal network operation as the water flows through the pipes. And that's mainly due to changes in flow. So without the actual presence of chlorine, we still get the accumulation of iron and manganese, but it's at a much lower rate, and therefore we tend to get less, and that's probably borne out historically, less dirty water complaints. So the brown colour is caused by iron hydroxide particles, and the iron's naturally present in the groundwater, and it just precipitates in the system. So part of the roadmap really is to address particularly the levels of manganese in the bores by either finding low manganese bores or installing manganese removal technology. And within that, we would remove iron also.
Thank you, Peter. So why did we actually need to add chlorine to our water to begin with, Kath?
Yeah, so in 2017, as Peter alluded to earlier, council had 5 E. coli readings in our network, and some of those were in reservoirs and some in the pipework. And we weren't able to determine, understand the cause of those. So we met with our regulator, so the local public health unit, the drinking water assessor, and together it was decided to chlorinate the network. And I guess it's worth noting that this was in the aftermath of the Havelock North incident. So our priority as council is to make sure that our people are safe. So that was why that decision was made at that time.
Thanks, Kath. And we now have another question for you, Peter. Isn't our water pristine? Why do we need to treat it, especially if our bores are in good condition? Why can't we just remove the chlorine?
Yes, you are correct. The aquifer that supplies Napier's water is of high quality and has historically been classed as secure. However, under new regulations, this secure bore status has been removed. So we have to at least have a minimum of UV treatment for the inactivation of organisms or protozoa such as cryptosporidium. So chlorine is added water not only to kill any pathogens from the source water, but also to protect the downstream water system, including reservoirs and pipework. And this is from opportunistic pathogens which can enter the system through ingress or accumulate over time within the network. So it's really understanding why chlorine is there and its main purpose, which is really the downstream protection of the network. And in order to then remove that, we have to be as clear as possible that network and that system is safe and secure from ingress. And unfortunately, at the moment, we're not in that position.
Another question for you, Peter. Do some people get more chlorine in their water than others?
Well, the simple answer is yes. However, I don't think that's just a satisfactory one. So this is really due to what we have to do is maintain a chlorine residual throughout the extent of the network. So the network is hundreds of kilometers long. And so in order to maintain that, we have to have a dose at the beginning of the network, and that has to persist throughout the whole of the network. So obviously people closer to where the chlorine's dosed would probably have a slightly higher chlorine residual to people at the very end of the network. However, the chlorine demand in Napier's water system is low, and obviously that means it doesn't decay because it doesn't react with contaminants in the water because there are very few of them. And therefore, that may be why it persists a bit longer in the system and at higher levels. But the other thing we're looking at is better engineered solutions as well. So make sure that we get a better dosing and control of the chlorine, so we can manage that system, so we don't get peaks or high levels of chlorine because there's changes in flow and things like that. So the short answer is yes, and within the master plan there's a strategy to improve the chlorine and the dosing and control of that. So things will undoubtedly get better as we invest in the system.
Great, thank you. Got another couple for you, Peter, and then we'll give you a break and move over to Tony. But the next one, Peter, is what are the risks to our water supply?
Yeah, so again, basically risks is from three areas: source water contamination, which we've sort of touched on, ingress from leaky pipes and reservoirs, and then thirdly from sort of human intervention during operations and maintenance. So what the strategy has developed is, one, let's better understand the risks and then identify how we mitigate them through the investment in the infrastructure, investment in monitoring, and also investment in people through training as well.
And following on from that, what options are there other than chlorine to keep our water safe?
Okay, so the strategy sort of aims to provide public health protection before, during, and after the transition from status quo to chlorine-free. So one of the reasons for maintaining the chlorine residual is provide the protection within the network from the opportunity pathogens that have been mentioned previously, and also the sort of what undoubtedly low levels of ingress in the system. So globally, chlorine and its derivatives such as chloramination are the most widely used since they provide the residual in the network, and that's one of the requirements under the regulations, that we have to have a disinfectant residual. So you'll heard of things like UV and ozone and chlorine dioxide. Now, they're all good for what we call primary disinfection. So they will disinfect the water at the point at which the process occurs, whether that be UV or we add ozone or we add chlorine dioxide. However, they don't provide a residual, so they don't persist in the network. And therefore, that's why chlorine and its derivatives have been adopted globally as really the best chemical disinfectant that we have at the moment in a chlorine-free system. So it's just that's basically really where we are. There are really no real serious alternatives to chlorine in a system where we have to maintain a residual.
Thank you very much, Peter. So Tony, this one is for you. If we can provide chlorine-free taps, why can't we provide chlorine-free for every household?
I think, as I said in the presentation, we did investigate point-of-use devices as part of the strategy, and it's documented in the report for those who are really interested. But really, the ongoing operating and maintenance costs were really found to be prohibitively expensive, particularly the annual replacement of things like UV bulbs and carbon filter cartridges, which also presents a sort of disposal and environmental challenge as well. So you would think there are maybe up to 20,000 properties in Napier, all requiring annual maintenance and replacement of bulbs and cartridges. And on top of that, I think, as we pointed out in the presentation, we would still have to do all the other investment as well. So it just unfortunately doesn't financially stack up. And then I guess the other thing is it's very difficult at this stage to understand what the sort of adoption community-wide would be. If it was one or two people maybe, or handfuls of people, but if you got widespread adoption, then all we would be doing would be further increasing the costs of the overall strategy.
Thank you, Peter. Kath, this one's for you. How will the national changes to Three Waters governance affect our plans?
So I think the main thing to think about here is that we've got a new regulator coming in, and we've got the Water Services Bill and new drinking water standards. So those are the elements that are sort of, I guess, overlaying over the work that we're doing. We've been assured at a minister level that if we have plans to go chlorine-free, that this won't impact that. So I think the main thing for us is to understand what Tō Mata Arawai, our regulator, would require of us to be able to go chlorine-free, and for us to map out that journey. My understanding at the moment is that They're working through a process of gathering guidelines for chlorine-free exemption, and they have 4 international experts who are pulling these guidelines together. So at least that will then give us more information around what that process might be. So it is definitely still in the legislation. There is an exemption pathway. They are pulling together guidelines. And once those come out, we can then look at those against the work we've done in this plan and then see what the next steps from there would be.
Great, thanks for that, Kath. Now we'll move on, and Tony, if you could answer this one. What will it take for Napier to get a disinfectant residual exemption from Taumata Arawai?
Okay, you can hear me now?
We can, thank you.
Right. The approach outlined in the report articulated a pathway to chlorine-free based operation. I'm providing evidence to Taumata Arawai. It involved the sampling and testing of the water system such that it's operated in a manner that maintains water quality and prevents contamination of the water for ingress during the supply and distribution. One of the key benchmark measures is to show that levels of leakage are being achieved and systems and procedures are in place to identify leaks in a timely and efficient manner and to minimise public health risk. This is not an easy task, and the council will have to take this seriously and understand there's a lot of hard work to get to the residual disinfection goal.
So we'll follow on for another question for you, Tony. Why does the report advocate for water meters? Does this mean volumetric charging would be a part of the plan?
Good question. I mean, water meters are part of the reason we've got water meters in the report is not to charge people, but more as a leakage and water loss management tool. So in order to say to Taumata Arawai, that we've demonstrated that our leakage is under control, we need to be able to understand how much water goes into the customer's property and how much is where our water's going. And furthermore, a lot of leaks on customer properties are there, yet without a water meter, they're unable to know that they've got leakage in the house. So there's the additional benefit of you'll be able to find that leakage and keep it under control. And
so certainly a number of benefits to introducing meters, and it doesn't necessarily mean that will lead to charging, which I'm sure many people would be relieved to hear.
Yeah, it's highly controversial, and you really want to make sure that people see water meters and they think I'm going to get a bill. Well, that's not necessarily the case. It's more for keeping a good track on what's happening with the water and where it's going.
Yeah,
and
exactly.
And in the wider report, one of the things we've done is looked at what we call a smart water network, which is really understanding where your water is going, and the only way you can do that is measure it.
Exactly. So a question for you now, Peter. If we do move towards a chlorine-free network, will chlorine use still be required from time to time?
Yes, it will. Mainly, it will be really around water hygiene during the main replacement and rehabilitation programs. And really, this is just to ensure that any new pipe work that is in the system, or any repairs or any interventions where pipe work comes into contact with humans, are sterilised prior to being used to transport the water. So, and this is common practice everywhere, even in the chlorine-free systems globally, that chlorine still offers those benefits of that sort of sterilising of pipes before they're adopted, or any programs associated with mains rehabilitation where there's a human interaction with the pipe. We'll also probably need to maintain some emergency chlorination, and this is just really to deal with any unusual events if the network was severely damaged, maybe in an earthquake. So it's part of the recovery plan. So that would only really be sort of short term, really, to protect customers and the network. So hopefully that answers the question.
It does. Thank you, Peter. So, and we'll stay with you for the next one. What can the Dutch experience teach us?
Well, the main thing it teaches us is that we can actually successfully operate a system without chlorine. But it also teaches us that there are operational maintenance and cultural aspects which must be addressed as well. So the Dutch place a very high value on water. I know the community in Napier puts a high value on well. It's very sort of proud of its water system, both the community and the council as well. But that, I guess, that also means that in order to maintain that relationship, that we need to accept that will require investment as well. So it's important that there's that relationship. Well, not only water is important, but there's trust in the water supply as well. And it's important that on this journey that the community comes along with us, and that trust is enhanced, improved, and maintained as well. There's also the important lesson that we learned really was this sort of high level of water hygiene, the end-to-end product, and that's really ingrained culturally throughout the organisation, both from the top down, both in terms of the importance hygiene has in terms of public health, but also in the day-to-day operations as well. So that's really making sure that there's an awareness of the role of the individual in protecting the hygiene of the water as well. So whether that be in the day-to-day operations. Finally, the use of technology as well. So very much around use of technology to be proactive around the management of the system and water quality. So they're all sort of valuable lessons I think that we've learned and things that we've adopted as part of developing the strategy.
Great, thanks, Peter. Might move Tony to you for this next question. Obviously, late last year here in Napier, we had a significant heavy rainfall event, and will the network be safe from heavy rainfall events?
The water system's pressurised, so minimal leakage happens, and it provides a protection against ingress. You had your recent storm and rainfall events, and they did not cause any detectable deterioration in water quality that was tested at the time. And it was sampling analysis carried out by the water team that really, proved to us that the network is safe from stormwater ingress. I think the thing is that you want the bores to be above ground and keep those high, so that when it does rain and flood, that it doesn't sit over the bores and make its way in through sort of groundwater into reverse its way into the system.
Oh, well, it's pleasing to hear that we did actually gain some decent information out of the unfortunate rainfall event.
Yeah.
We always like to focus on any clouds and silver linings in the clouds. We'll move back to you now, Peter. And why do we need to increase the quality of monitoring for our water supplies?
Okay, so one of the approaches to getting the exemption is really going to be evidence-based. And that really has to show that we are able to demonstrate good custody of the water throughout its transmission through the system. So we have to, first of all, establish a good baseline. So what's the current performance? And then as we move through the investment program, what we'll be looking for is improvements in that baseline of water quality. And this will all be part of the information gathering to demonstrate that we are able to maintain and improve quality in the system as we make the improvements. And this will be all part of the evidence that we'll need to provide to gain the exemption.
Thank you. And we'll stay with you. The use of chlorine creates disinfection byproducts. What risks can these pose?
Okay, so some disinfection byproducts have been around ever since chlorine was first used over 100 years ago. However, it was only in the sort of 1970s that they're actually identified for the first time in water supply. So that doesn't mean they weren't around before that. It's just that scientists actually discovered and found ways to analyse and monitor them. I think it's important to remember, particularly in Napier's case, that there are 3 requirements for producing disinfection byproducts. Just adding chlorine to water doesn't produce disinfection byproducts. You need other things. So you need to have what I call precursor material. So that's organic material. So the chlorine has to react with something to produce a disinfection byproduct. And that's generally organic, natural organic matter that's present in water. You also need to have chlorine, obviously, and you need to have some time. The good thing about the Napier system is the aquifer that serves is very low in organic material, and therefore the potential to form disinfection byproducts is extremely low, well below the standards in New Zealand and also adopted in all major developed nations around the world as well. And this is backed up by the sampling and analysis that Kath and her team have carried out. So before we actually get on to the fact whether the risk or the risks of them being present in the Napier system are extremely low. And the evidence that we have to date shows that they're pretty much at or near the limits of detection. Further, the main disinfection products that are of concern are the ones where we have the bromine present. So they have what they call brominated disinfection byproducts. And without the presence of bromine, you don't get brominated disinfection byproducts. And again, there's no evidence of any levels of bromine that give any concern in the Napier system. So in countries where I guess they do have a disinfection byproduct problem, again, there's no real statistical evidence that points to this having widespread health concerns. So I don't really think for the Napier system that disinfection byproducts are a major factor and a major concern for the community.
Thank you, Peter. Now, Tony, a question for you. Why is leakage management important? Are automatic leak detection and response initiatives being considered?
Well, leakage management, it is important. And one of the things we did at the beginning of the project, we went and looked at what practices people who were running chlorine-free networks were looking at. And one of those practices was low levels of leakage were consistent across these networks. And leakage is really an indicator of system integrity. I mean, if the pipes are leaking, you know that there's a lot of holes in them, a lot of points of leakage. So it's a good indicator of how good a condition your water network is. The roadmap we put in place recommends a smart network, which is metering and pressure sensors and really putting indicator or putting parts of the network into zones so you can manage them, and that'll give us some real-time information on system operation and general health, and will identify leaks early and trigger responses. So yes, it's important and it's in part of our plan.
Great, thank you. So this brings us to our final question, which I'll pass over to you, Peter. There's a significant capital program being planned. How many jobs would the chlorine-free option create?
Okay, so the program work extends, I think I'll be outlined, for maybe 15 to 20 years. And we think that will create a number of permanent jobs, as well as attracting outside labour into the Napier area, again, which has secondary benefits for the service sector in the economy as well. So very difficult to put a number on it. Certainly there'll be jobs created within the CAP and the water team, and then jobs created for the infrastructure required, and they will be sustainable jobs because of the period of investment. I mean, there are sort of reports out that people can find that have been done by some international water organisations that sort of say potentially maybe between 10 and 20 jobs being created per $2 million invested. Now, I'm not going to say whether that is applicable to the Napier system, but I think people can be certain that jobs will be created. There'll be good jobs, There'll be skilled labour force jobs, but at the moment I can't be certain on the numbers that can be created at this level in terms of developing the plan.
Thanks, Peter. And I guess just to provide some context about the degree of the capital program, in our current long-term plan that we're out consulting on at the moment, we've got a capital program proposed of 825 million over the next 10 years.
Yeah.
And of that, 404 million of it is related to our Three Waters capital program. So I guess that clearly reinforces that water is our #1 priority, and that we're really committed to not only working our way towards a chlorine-free network, but ensuring that we have a really modern, up-to-date stormwater, wastewater and drinking water infrastructure for our community. So certainly a very significant capital program in place there. So that actually brings us to the end of our guest lecture today. I would like to say thank you very much to Kath, Peter and Tony for joining us to both do the presentation and answer the questions that we've put to you today. Also, just a reminder for anyone that is watching the guest lecture and would like some additional information, we do have both the PDP report and the GHD peer review reports available on our Napier City Council website. And certainly, if you were wanting to ask additional questions, then you can come to us via our customer services online function on the website as well. Fire that through and our team can respond to those to you. So I hope this has been helpful to anyone that's taken the time to view, and we'll be signing off now. So once again, thank you to all of our panel today for taking part. Thank you very much.
Thank you.
Thank you.
Thank you.